Hello, and welcome to the 700 Club Worksheet 1, where you might be thinking, what is 700? Well, a very high SAT score would mean you'd need to get around a 700 in math and a 700 in English. So once you get over a 600 and you're shooting for a 700, what type of problems are keeping you from that goal? Are some very difficult problems. So if you think these are hard, you're right. These are sneaky, sneaky hard problems. Let me explain what synthetic division is. Okay, a couple of vocab words are going to be important here. Factor, divisible by, remainder, and long division. Okay, so synthetic division is the application of these terms to a polynomial. So let me explain. When you see a fraction like this, 10 over 2, you think, oh, 10 divided by 2 is 5. So how did we do this back in the day when we did long division? We did 5 times 2 is 10, and we distributed a negative through and vertically canceled this out. 10 minus 10 is 0. So you might also think you could rewrite this 2 times 5 plus no remainder is equal to 10. 10 is equal to 2 times 5 and nothing left over. So let's do an even sneakier one. When I think about, let's say, 155 divided by 5, I could use long division. And notice what we do here. 5 doesn't go into 1. So then we think about these two numbers instead of just the first number. And we come up with the number 3. 3 times 5 would allow this 15 part to cancel. Not the whole part, but these two terms. So we distribute a negative and we get 0. So remember, next we do this drop down thing. So the 5 drops down and we do this again. We say what times 5 would get 5 to cancel out. And so we say 1 times 5 would get 5 to cancel, but we distributed a negative through here. So what have we done? Well, we've restated that 31 times 5 and no remainder would be equal to the term 155. And that's a true statement. So now let's add in a remainder here. We know if we did 156 divided by 5, that there would be a remainder here because we're kind of forcing it. So once again, kind of repeating these steps, we get 1 times 5, distribute a negative, and we get 1. So what have we said here? Well, we've actually said two different things here. We could say 31 times 5 plus 1 is equal to 156, because we know this part is equal to 155. But what did we really say a minute ago? We said we wanted to divide. We didn't say what is equal to a 1 plus the 156. When we started, what we're really saying is how much is this worth? So this is actually worth 31 and 1 over 5. It's 31 even and then 1/5 remaining. So you can think of it as 31 and 1 over 5 left over. So if you really did divide it, it's the same as 155 over 5 plus 1 more fifth, giving you 156 fifths. Okay, so now what? I feel like maybe you already knew this, but we're going to use this to apply to polynomials. So going back to our vocab words, we know what a remainder is. We reviewed long division, but what are these two terms and why are they going to be important? Okay, so here we see again that because 5 and 31 neatly came out of the 155 with no remainder, we could say 31 is a factor, or we could have said that 5 is a factor of 155. But here, since 5 did not go into 156 neatly, we must say it is not a factor. Okay, now last term, and then we're going to start in with these math problems. Divisible by. Well, we could swap out the word divisible by instead of the word factor. So we could say 155 is not divisible, or is divisible by 5 because we got no remainder. We could say 156 is not divisible by 5 because we got a remainder. So we're using it in the same way as factor. Let's start these math problems. Okay, so question number 1, it says the expression 4x over this is equal to what? So just like we did a minute ago, 10 over 2 could be written like this. So we're going to rewrite in this fraction in the same fashion. We could say this is the same as 4x over x minus 2. Now this looks really weird, so I'm going to help you out here. If you add that, it'll look like it'll make more sense here. Okay, so we're saying what times this stuff would help this cancel? So hopefully you're thinking a number 4, and what we're doing here is exactly what we did a minute ago, but be careful. We are distributing. So we are distributing a 4 to both of these terms and then putting it down there. So 4 times x is 4x. 4 times a negative 2 is a negative 8. Now, just like we did a moment ago, we must distribute this negative through that term and then vertically cancel this out. Okay, so 0 plus 8 is 8. All right, so now what do we have? We have a remainder of 8. So what does that mean? It means when I divided this by this, I got 4 and 8 over x minus 2 left over. Okay, so what is it equal to? Notice C is matching my work here. Do you see that? So this is 4 and 8 over x minus 2. So my answer is C. Let's try another one. Says if the expression, there it is, and once again, that's the part we're going to put under here, and divided by 2x plus 1. All right, so doing the same thing. What would make this cancel? I'm hoping you'd come up with a 3x, because 3x times 2x is 6x squared. And then again, I'm going to distribute this to both terms. So some students might write this off to the side until they get the hang of it. So the second one would be a plus 3x. Now I'm going to distribute a negative through. So when I distribute a negative here, this cancels, goes away. 5x minus 3x is 2x, and this drops down. Beautiful. Now all I have left here is a 1, because 1 times 2x would make that cancel. So 1 times 2x and 1 times 1. And don't forget to distribute this negative through here. So 2 minus 1 is 1. So we got an answer of 3x plus 1 and 1 over 2x plus 1 as a remainder. So looking here, it says this part we got, that's the part I have here, this part I have, and this is the Q part. So this is the Q they're looking for, which is why I got, this is my answer, 3x plus 1. Hopefully you're getting the hang of this. Let's try another. The expression can be written as this. Okay, so we said this a minute ago. We can rewrite it in this way, and I showed you the 2 ways to write that. So this would be the same as saying 4x squared plus 5. What if I divided it by this term? Would I get a remainder? Okay, so let's do that. I get 2 times x would be 4x squared minus 2x. And now we see these are like terms, but those aren't. So I'm going to give you another tip. If this is going to work, I'm going to have to write 0x plus 5, right? I didn't have any terms with an x, but this will allow me to cancel here appropriately. Okay, so we must distribute a negative through, and we get 2x plus 5. Now this worked out nicely. I just need one more 1. 1 times 2x is 2x. 1 times a negative 1, negative 1. And I distribute a negative through. I get 6. So here's my answer. And then they said in this different format, what does this look like? So A would be this part up here. So what they're saying is 2x plus 1 times 2x minus 1 would have to equal plus 6 would have to equal what we started with. And you could actually do a little math to just double check. This is what we're saying. So they said, where A is an expression and R is a constant, what is the value of R? So we notice our remainder was the number 6. So that's all we have to write for the question. All right, let's try to do one more. So it says, the function g is defined by a polynomial, and the table above shows some values. What is the remainder? So we know if g of x is divided by x plus 3, if x plus 3 is a factor, then we know that if you set this to 0, you get x is equal to negative 3. So when f of x is 0, it is a factor, and when f of x is negative 3, if it were a factor, it would be 0. Okay, but it doesn't say it's a factor. It merely says, what remainder would you get? So this is another way to figure that out. Our table says when g of x, when I plug in negative 3, I end up getting 2. So notice I don't get 0. I end up getting 2. And so that's a way to see that that would be my remainder. Pretty cool, right? Awesome. Check out the next video for the next answer.